Please, go ahead.
Teamwork for
Dreamwork.
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 Good afternoon. Thanks to honorable judges and audience. Welcome to our presentation. Savings of purified water is above 80% during cleaning of granulation unit. We at the team
Leading Light.
We are from production department of Beacon Pharmaceutical Limited, Bangladesh. Member introduction. We are 5 members in our team. We are 3 present here. We would like to introduce ourselves.
Myself, Mohammad Shahad Hussain, member of team.
myself Mohammad Alamgir Kabir, member of team.
Myself, Tanvir Ahmed, leader of team. Our another 2 members, Mr. Riazul Islam and Mr. Shohidul Islam. Our facilitator, Mohammad Saiful Islam. Our company profile.
Beacon Pharmaceuticals Limited, the state-of-art manufacturing plant in pharmaceutical product. Our Mohammad Ibadul Karim, our honorable managing director and founder of the company. Our company vision is
To be recognized as value-driven pharmaceutical company in the country.
and our company mission is
To improve the quality of human life by innovative pharmaceutical product.
At a glance, our company profile.
Beacon Pharmaceuticals Limited has started its journey in 2006.
We have more than 2,000 employees.
Beacon manufactures more than 215 general products and 70 oncology products.
Now we are the #1 anti-cancer manufacturing company and one of the fastest growing pharmaceuticals company in Bangladesh.
Beacon supporting hepatitis and cancer patients in more than 104 countries globally. Our circle information.
Circle name,
Leading Light,
date of formation,
2nd May 2017,
team members,
5%
meeting day,
every Tuesday
meeting time,
from 2 p.m. to 2:30 p.m.
Our slogan is teamwork for
Dreamwork.
our topics.
Our topics is savings of purified water is above 80% during cleaning of granulation units.
We used PDCA cycle for graphical analysis. Plan, do, check, act.
In plan phase, we have performed
Problem identification and priority analysis.
Duration 2nd May 2017 to 9th May 2017.
in do phase, we have performed
Root cause analysis, data collection, bar chart analysis, cumulative analysis, and 5W1H analysis.
Duration 10th May 2017 to 23rd May 2017.
in check phase, we have performed
Cost benefit analysis and cleaning trial.
Duration 24th May 2017 to 13th June 2017.
and finally in act phase, we have performed
Implement the feasible solution, review of all documents, and conducting training.
Duration 14 July June 2017 to 6 July 2017. After brainstorming, we have identified 5 problems.
problem 1, printing not performed though the system is available with FBT and RMG.
Problem 2, high consumption of purified water during cleaning of granulation unit.
Problem 3, higher capacity but low output of EMA tablet compression machine.
Problem 4, granulation time is more for some products.
Problem 5, overloaded tablet compression and coating machine. We use Matrix tools to set priority.
Here you see that number 1 is costly, team cannot solve, less important. Number 3 is moderate cost, moderate important. And number 5 is less cost, feasible for team, it's important. According to the matrix tools, we evaluate our 5 problems against cost, feasibility, importance and frequency. Then calculate the total value. Let's see the first priority problem. Yes, number 2 has got the first priority because it obtained the highest marks.
So, problem selected on priority basis.
High consumptions of purified water during cleaning of granulation unit.
Problem description. There are different types of water like potable water, hot potable water that can be used for cleaning purpose of the machinery in pharma industry. But the connection of potable water line and hot water line are not available in a 3 granulation unit. So we use the purified water, the costly item for cleaning purpose of this unit, resulting high consumption of purified water. Our system description. We have 3 granulation units of defined model and defined capacity. They are from the same origin, NR Industries, Thailand, and each unit contain high-speed mixer, fluid bed dryer, and lifting machine. Here we have shown our process flow. We used high-speed mixer for
Mixing of all ingredients to make white mass.
we used fluid bed dryer for
Drying of white mass for proper granules.
we used lifting machine for.
Milling of dried mass to make granules for tableting.
Before modification, the cleaning description of this unit. To clean high-speed mixer,
There are 5 steps of cleaning.
to clean fluid bed dryer,
There are 4 steps of cleaning.
and to clean lifting machine.
There are 2 steps of cleaning.
And all those steps, we used only the costly item purified water for cleaning purpose, resulting high consumption of purified water. So, The previous consumption of purified water for garrison unit M600 equal to 1910 liter, for garrison unit M150 equal to 900 liter, and for garrison unit M60 equal to 650 liter. So our project target
is savings of purified water is above 80% during cleaning of garrison units.
The duration May 2017 to July 2017.
We used fishbone diagram for root cause analysis where the effect was high consumption of purified water during cleaning of garrison unit.
And the main causes are man, material, machine and method, where attitude and awareness are the sub causes of man. Supply of potable water and supply of hot water are the sub causes of material.
Undefined SOP and insufficient cleaning test are the cause of method. And finally, absence of potable water line and absence of hot potable water line are the sub cause of machine.
We used matrix tools for Pareto diagram.
According to the matrix tools, we evaluate our 8 causes against cost, feasibility and importance. Then calculate the total value.
Data for Pareto analysis.
We have sorted our 8 problems from largest value to smallest value. Then calculate the cumulative value and the percentage of cumulative value.
Pareto diagram. We used Pareto diagram for statistical and graphical analysis. We plotted the causes matrix data against cumulative percentage from the Pareto diagram. If we work on 2 problem, our 80.95% problem will be solved. Gantt chart for project timeline management.
The overall responsibility is on reading line. Here, plan is indicated by orange color, done is indicated by green color, and festival holiday is indicated by gray color. We have 4 tasks. Task number 1, problem identification and overall planning. The planning duration was first week of May 2017. Task number 2, analysis of the problem. The planning duration was second and third week of May 2017. Task number 3, cost benefit analysis and cleaning trial. The planning duration was fourth week of May 2017 and first and second week of June 2017. And finally, implement the feasible solution, review of documents and conducting training. The planning duration was third week of June and fourth week of July 2017. And reading light team successfully completed all the tasks within due times.
5W1As. We used 5W1As for solution of the problem, question and answer.
Questions. Where is the problem?
In 3 generation units.
Why? Why is it a problem?
Because no facility to use potable water and hot potable water in generation area.
What to do?
We have to arrange the connection of potable water line and hot potable water line.
Who? Who is the responsible?
QC circle, reading line.
When to do this task?
From 2nd May 2017 to 6 July 2017, that's 9 weeks.
How to do?
We need the help of engineering team and expenditure approximately 3000 taka.
Pictorial view of correction.
In left side you see that before modification there was only purified water line.
After modification, now potable water line, purified water line and hot potable water line are available in generation area.
Let's see a video for modification. Here you see before modification only purified water is available, and we used only purified water for all steps of cleaning. And after modification, the potable water line and hot water line and purified water line is available. So after modification, we are using 3 types of water for cleaning purpose in different stages. Cleaning description after modification, cleaning description of high-speed mixture.
Before modification, we used 100% purified water for all steps of cleaning.
After modification, now we are using potable water for first, third and fourth step cleaning. We are using hot water for second step cleaning. And finally, we are using purified water for final step cleaning.
Cleaning description of fluid bed dryer.
Before modification, we used only purified water for all steps of cleaning.
After modification, now we are using hot water for first step cleaning. We are using potable water for second and third step cleaning. And finally, we are using purified water for second and final step cleaning.
Cleaning description of lifting machine.
Before modification, we used only purified water for all steps of cleaning.
After modification, now we are using potable water and hot water for first step cleaning. And finally, we are using purified water for final step cleaning.
Dear honorable judges, for your kind information, we have not changed the total cleaning time and total requirement of water. We only replaced the potable water by purified water. We only replace the purified water by potable water and hot potable water in some cleaning steps, where the hot potable water has enhanced cleaning efficiency due to its higher solubility effect. Pie chart for water requirement.
Before modification, we used 100% purified water.
After modification, now we are using purified water only 13.91%, potable water 54.18%, and hot potable water 31.90%.
Cleaning and QC test.
We perform cleaning trial and send sample to quality control department for residual test. Yes, finally we have got successful cleaning result.
Bar chart for comparison.
Yes, we have successfully minimized our purified water consumption from 100% to 13.91%.
So saving of purified water is 86.09%.
Cost and benefit analysis of our project.
Here we have shown that the previous requirement of purified water per cleaning and the present requirement of purified water, potable water and hot potable water per cleaning.
Now let's see the value of different types of water. Here, potable water cost is 0.02 taka per liter, hot potable water is 1.56 taka per liter, and purified water is 2.52 taka per liter. Then we have calculated previous costing of purified water per cleaning and present costing of purified water, potable water and hot potable water per cleaning. From previous costing and present costing, we have calculated saving per cleaning, and from production equipment logbook, we have calculated 6 months average number of cleaning, where 7 times cleaning required for granulation M600, 3 for granulation 150 and 1 for granulation 60. From average number of cleaning per month, we have calculated average saving per month and average saving per year.
So let's see what is our project benefit, tangible benefit.
Yes, from 3 granulation units, we can save per year 3,24,483 taka or 4,056.05 USD.
Where the total cost for correction is only BDT 3000. Our intangible benefit.
Self-development increased.
Teamwork and spirit is increased.
Friendly working environment has generated and finally the total environment has set.
Now, time to standardize our system. As for our correction, we have reviewed our standard operating procedure. Here the approved copy of our standard operating procedure, and here the training copy of standard operating procedure, and here the evidence of our training session. We used 9 QCC tools to complete our project. Tools and purpose: PDCA cycle,
For graphical analysis,
brainstorming,
For problem identification,
matrix,
for setting priority,
fishbone analysis,
for root cause analysis,
Pareto diagram,
for statistical and graphical analysis,
Gantt chart,
for timeline management,
5W1A's,
for solution of the problems,
pie chart,
for graphic analysis.
bar chart.
for comparison.
So our project summary. Our project target was savings of purified water is above 80% during cleaning of reaction unit. The QCC team leading light has achieved and reached on the target. Yes, we have saved. Purified water is 86.09% during cleaning of reaction unit within the time frame. Our ongoing project is
Increasing the productivity of IMA tablet compression machine.
Thank you, Rajesh and audience. Have a nice day. If you have any question or suggestion, please ask.
Congratulations. You've modified your process by using different types of water, right?
Yes.
Okay. Your problem is you're consuming too much mineral water. Water. What do you call it? Purified water. Sorry, during cleaning, and then you did your fishbone. I just could not understand your matrix in your fishbone. On the person, you said here why, and then the underman attitude. I could not get the criterion of cost. On how will you apply cost here? How did you rate cost?
Thank you for your
In the
question.
matrix, show the matrix, please. Forward. 22. After that, that's the matrix. Next one. And you rated already cost. This is just the cost analysis, right?
Thank you
Part of
for
the
your
cost
question,
analysis,
sir.
right?
It is cost analysis. I mean attitude. Your question why attitude is one.
Okay,
Yes, sir?
attitude is one.
Yeah, attitude. I think attitude is more difficult to change. It needs some training or some motivational work for changing one man. So I think it is costly. ICQCC team
Should
think
it be
is
the
costly.
cost is much higher?
Yeah.
Should it be the cost is much higher?
Yeah, cost is higher. So, but cost is one.
Well, that's
Because
costly.
costly is one.
And then you got the absence of hot potable water in the on the 7th and the 8th costs. Aren't they your solutions already? The potable and hot water.
Yes.
We use.
Now we are using.
Yeah, we are using.
Why did you mention here that as part of the cost, there's an absence of potable water line and the hot potable water line
Yeah.
as cost? Is it a standard in your company as to use these two during cleaning?
Yeah, earlier when we designed the facility, the connection is not directly into the place. It was in the technical area. But if you can take the line to the working area.
I mean, do you have other area wherein you clean and you have these two?
Yeah.
Yeah.
Only in the
Granulation.
granulation area you don't have this
In other area, it is available.
available. So
Yeah.
that's why you mentioned this is the cost. We don't have this, that's why we're using too much mineral water.
Yeah.
Is that what you're saying?
Right. Yeah.
Now, what's the reason? How come in this area you don't have this?
In our company, a hot water line, potable water line, and purified water line are available. Okay, but in granulation area, near granulation area, the connection is not available. Before we are using.
Why?
It was designed earlier in this way.
That's what I'm looking for.
Yeah.
By providing potable and hot potable water,
Yeah.
The QCC team
Ah.
identified.
that is not the root cause. That is your solution, right?
Yeah.
But you will not prevent this problem from recurring in the future, since the root cause is when you design something, you forget to put something.
Yes.
So it should be in the standardization, you focus on completing whatever resources you need in a certain area.
Yeah.
Correct?
Yes.
We complete in certain area, but gradually we do the same thing in the other area also.
Okay, but what I'm saying is like this. We know already that there's an absence of hot and potable water, right?
Yeah.
Okay, you provide them.
Yeah.
But we did not solve the problem yet. Because every time you put a facility, it might be forgotten again. So what error or what caused that error in your process of designing a place
Yeah.
Yes.
that you forget to do something?
Yes, sir.
It's not forgetting. Earlier the design was done like this, and in the next project and in the next step, we'll change the whole area. We will provide.
You will
portable-
include already.
Yeah.
But again, that's because you know that you have to put. But what I'm asking is the root cause. We're forgetting something. So the process of the design should be the focus here.
Thank you, sir.
Maybe it's next time you put a facility, it's not water. Okay? Maybe it's something else. So we tend to forget to provide the right resource
Yes.
when we put up a facility. So maybe it's not water this time. We're going to put a facility. So what I'm looking at is you must be able to detect the error in your design process, not the facility process, not the facility lacking.
I get your point.
You get it?
Yeah, I get it.
All right. So for the future.
Yeah.
Okay. Thank you.
What is the cleaning requirement for your equipment? From your QA, you have a report that says the residual
Yeah.
minerals are at these levels. What are those residual minerals?
Yeah,
And
after
those
cleaning,
are those residual minerals not present in potable and hot water?
Thank you, sir, for your question. We used purified water before purified water, and it is now we are using potable and hot water. You know, hot water is enhanced cleaning efficiency due to solubility effect. It can remove the product residues better than purified water. Okay, and purified water and potable water, it is permitted for solid dosage form. We are our production area is solid dosage form. We are manufacturing tablet, capsule, and powder for suspension. And potable water and hot purified water both are permitted for as per guideline for cleaning purpose of the machineries.
So why not remove altogether the potable water and just use hot water?
There is 5 steps of cleaning. Initially, we use 4-step cleaning: potable and hot water. Potable water and hot potable water. In the final step, we use purified water, which is more purifier. And in the cleaning step, there is a limit spec set by the quality assurance department. There is 10 ppm, 10 parts per million, not more than should be present.
Of what?
Product
Particle.
residue.
Product residue.
Not
Product
particle.
residue.
Product residue.
Any residue?
Yeah,
Not
previous
more than
product.
10 ppm.
So, after cleaning with potable water, we ensure that there is less than 10 ppm.
And it's the requirement for cleaning.
Which is cheaper, hot water or potable water?
Yes, potable water is more
Potable and
cheaper.
then hot
Yes.
and then purified.
Yeah.
Okay. Your team was convened just this year, right?
Yeah.
Yes.
So for improvements, as what my co-judge has inputted, and also for your YY analysis, you should validate. You should answer the why.
Why?
The fishbone diagram. I think what can be improved in your project is your problem. The problem really is not the high consumption of purified water. Probably the problem is high cost of cleaning. And then why high cost of cleaning? Because the material used is purified water. Something like that.
Right.
And if you go through that point of view, the rest of your project would also be different. So it's critical that you follow the QC tools step by step. Okay? Thank you.
Thank you, sir.
Good presentation and very clear information on the problem. You have very you have given emphatically this problem statement. Then the step-by-step approach also good. Some of the points on the QC story I want to specify. One is go to your Pareto diagram. Yeah, the Pareto diagram have some grammar, isn't it? That was not adhered. The grammar one is you have to mention the period. On which period the Pareto diagram. It's very important because it's dynamic. So Pareto should have the period. It was not mentioned. One. Second, the scale. What is the scale you are for x-axis, y-axis? What is that? That you have to specify. In the vertical axis, what is the matrix data? What it means?
Matrix data, we got the matrix data from here the matrix data.
It's percentage.
First we calculated the data for matrix, then cumulative value, then cumulative percentage.
Okay.
And
Cumulative value.
This data, we obtained this data from the matrix, by matrix.
Matrix data you are taking.
Yeah.
Okay. 210 is the total value.
Yeah, 210 is
Go to Pareto. Then you have to fix that 210 is equal to cumulative 100%.
Yeah.
That is the grammar for Pareto.
Okay. Thank you, sir.
Okay. You have to fix that 210 is equal to cumulative 100%.
Okay.
Then only the Pareto will come correctly, or otherwise it will be like this.
Okay. Thank you, sir.
Okay.
For service.
So, but that is one point. You have to use the Wilford Pareto, whatever grammar he has given, that you have to observe. Okay. Yeah. Second thing, like the cause and effect diagram. Yes. Yes. Here, whatever you have taken as effect, okay. Then you have to see what is man, material, method, and mission. That you have to validate that each cause, maybe first level, it all the possible causes. Then you have to go for the probable causes and validate all the causes. Then only root cause will come. Validation means data-based validation. You have to take data and validate that, because it's all assumptions. All the causes, it's all assumptions through brainstorming. How it will come as data, foolproof data or root cause? Only by validating that cause, by data. So that part is missing.
Okay, sir. For future, we will.
Okay. Thank you very much.
Thank you, sir.
Good luck on your next project.
Thank you.